Going through the mathematics numeracy paper for the Calculator Allowed Unit 2 higher tier from the summer of 2018. Okay then, so first page is really easy. It's just said it's blank, don't write anything on this. So question number 1. Let's have a look what we got here. It says, in October of 2011, a 5p charge for a carry bag was introduced in Wales. Money raised from this charge is given to charity. For the period of the 1st of October to the 31st of January, it is estimated that there's a total of between £16.8 and £21.9 million was donated to charity. This was the result in people buying the 5p carrier bags. In this part of the question, you will be assessed on the quality of your organisation, communication, accuracy in your writing. Okay, so nothing too much to worry about there. All we have to do is make sure that we use any pound signs, any units, and just give an arrow sort of explaining what we're doing. So there's not just things popping up out of nowhere, no sort of random calculations, okay? Calculate an estimate for how much per month was given to charity between the 31st of October 2011 and the 31st of January 2015. Okay, the way I'm going to start this, say 2011, we've got October, because it's from the 1st of October, so we've got all of October, November, and December, and then that's the end of 2011, so that's 3 months there. 2012, we've got 12 months. Just go back and write the months. 2013, we'd have 12 months. 2014, we'd have another 12 months. And then 2015 is up until the 31st of January, so it's literally just 1 month, which is January. So Jan, which would be 1 month. Okay, so the total months, again, don't just have things popping up out of nowhere now. Total months would equal 12 add 12 add 12. So 3 lots of 12 and 3 and 1. Okay, 3 times 12 is 36. Add 3 add 1 would be a total of 40 months. Now, in terms of how much money was raised, it says it's between 16.8 and 21.9. So I think it's probably a good idea to just go in the middle of those two there. So I'm going to say the middle, finding... Let me just check if you can see what I'm writing. Okay, finding the middle of the money raised to be fair, that's why I'm doing it. It's not because I'm being like an optimist and saying, oh, let's say it's just the most amount of money, so it's the least amount of money. I'm trying to do it to be fair. So I'm going to do 16.8 plus 21.9 and divide that by 2 to find the middle. Okay, so estimate I get 19.35 mil. Now, because this is this type of question, make sure you put your pound signs in for anything like that, okay, for your final answers. Now, to work out how much money per month, I need to do the amount of money that was raised divided by the total months. So 19.35 million divided by 40 months. So fraction button, answer divided by 40 gives me 0.48375 million. Now, that's a really strange answer to have there, so I'm going to turn that into a normal number by getting rid of this saying it's 0.48375 million by timesing that by a million to change it into just a normal number. Okay, so again, I'm making sure that I've shown that step. So calculator, and times by a million, so 123, 123. That gives me 483,750, so £483,750 per month. Okay. Now, in terms of that, I think I've done everything that I need to do there. Part B says, over time, there has been a reduction in the 5p carrier bag, in the use of 5p carrier bags. This is because, let me just turn the visualize a bit more there. Hopefully it's a bit more straight now. This is because more people use their own bags. What impact will this have had on the amount given to charity for the month of September 2014 compared to September 2012? Well, if more people are using their own bags over time, we expect them to be using less 5p carry bags, so less money would be given to charity. That would be my assumption there. There's probably a few different ones that you could have to get the marks there. Okay, then over the page, it says Megan and Rodri both set out at the same time from home to go to a swimming pool. Rodri's journey by car is 5.5 miles. So this one here, I'm just going to use my highlighter. So his journey by car is 5.5 miles. So it's this long one here. 5.5 miles. And his speed, so I'll say D equals S equals 22 miles per hour. So that's already telling me that I'm going to be using my speed equals distance over time triangle. And we're told that Megan average speed is 12 miles per hour. She leaves 5 minutes before. Go and work out how long this distance is. That's what we've got to go into. We've got to work out how long the straight distance is. Now, my advice with any question like this is try and work out anything you can so far. You don't look all the way at the bottom of the question. Right, how would I do that? Start looking through this. It'll be given in an order to help you start answering it. Roger's journey by car is 5.5 miles. His speed is that. So I know two things there that can go into that. I can work out his time by doing distance divided by speed. Okay, so I'm going to say R, D is equal to speed. R, as in Rodri, his time would be equal to the distance, so 5.5 miles, divided by the speed, so divided by 22 miles per hour. So his time is 1/4, so 0.25. Now it's 0.25 hours, okay? Now, if I said to you quarter past, how many minutes is that? That's equal to 15 minutes, okay? So it's useful to have them in both in terms of hours and minutes to do some thinking of. We're then told that Megan's average speed, so we know her speed was equal to 12 miles per hour. She's slow, she's on a bike. And she arrives 5 minutes before Rodri. So we know her minutes. Okay? Now, the problem here is that when we're trying to work out the distance that Megan cycles, we've got this time in minutes and this speed in hours. They need to be, or miles per hour, it needs to be in the same unit of time. So to change 10 minutes into an hour, I would do 10 divided by how many minutes go into an hour, so divided by 60. And then 10 over 60 is the same as 1/6 of an hour. I'm just going to leave it as a fraction so I know that's a recurring decimal. To then work out the distance that she cycles, cover up the D, I want to do her speed, so 12 miles per hour times by the time, which is 1/6 of an hour. So Megan's distance would be D equals speed, so 12 times by 1/6, and 12 times by 6 is 2. So she is 2 miles. She cycles 2 miles to the leisure centre. Okay, moving on to the next question. It says, Gary travelled a distance of 200... Oh, let me make sure you can see the question. Gary travelled a distance of 231 kilometres in 3 hours and 30 minutes. What is, or calculate Gary's average speed? So again, we're using the speed, distance, time. Speed equals distance divided by time triangle. To work out his speed, kilometres and in kilometres per hour, this is your issue again. This says 3 hours and 30 minutes. It's got to be in hours because we're measuring it in kilometres per hour. Now, the main mistake people will do here will say his speed is equal to the distance, so 231, and they'll say this is 3.30, and that would be wrong. Okay? Now, if it's 30 minutes past, what's another way of saying it's 30 minutes past on your watch? It's half past. half as a decimal is 3.5. That's what we should have. Now, also what I'll show you that they'll do is if I put in 231 over 3.30, we get the answer 70. That's one of my answers, okay? They pre-think these things through to give you like an obvious answer. If I have it as 3.5 or 3.50, just change that to 3.5, you see the answer is 66, okay? Okay, next question, number 3. Yared is going to make a door wedge, and there we go. The cross section of the wedge is shown below. The horizontal length is 12. The vertical height is 3, so that's on the diagram. Calculate the answer of x, or the length of x. Well, that's knowing all 3 sides, so that's telling me to use Pythagoras. That's opposite the right angle, so that is the hypotenuse. So it's going to be 3 squared plus 12 squared is equal to x squared. I'll literally just go and put in 3 squared plus 12 squared into my calculator, press equals, I get 153. I'm now going to square root that answer. So square root answer. Write down if you're unsure. You don't have to if you're really confident with this, but never a bad idea to write down the whole thing. And then in the question it did say corrected 3 significant figures. So there's my first significant figure, so it's not 0. I've started counting, so I carry on. 2, 3, round after 3, so it would be 12.4. Okay. Next question says, the wedge must fit under Yared's door. The angle must be less than 15 degrees, show that the wedge will fit under Yared's door. Now, usually they'll just say something like, does it fit under his door? And you'll have to answer yes in a numeracy paper, so just be wary for that. I'm going to just answer it as if that's the question anyway. Going back to the triangle here, this is the angle, this is opposite the angle, and I know it, so I'm going to underline it. This is adjacent, and I know it, so I'm going to underline it. I do actually know what x is. It's a hypotenuse, but it's quite a long, horrible number, so I'm just going to leave that as blank for now. I already know 2 sides. Now, by writing out SOHCAHTOA and crossing out A's because I know it, and O's because I know it, tells me I'm going to use TOA. TOA stands for tan angle. Tan y is equal to the opposite side, so 3 over the adjacent side, so 12. Okay. Next, I'm going to get the y by itself by taking the inverse of tan, which is tan minus 1 of each side. So the way that I'll write that is tan minus 1 bracket 3 over 12. So y is equal to, so I press shift and tan to get tan minus 1, and then 3 over 12, close my bracket, I get the answer 14.0. So y equals 14.0 degrees to 1 decimal place. So does it fit under his door? Yes. Fits under door. Okay. The next question says, Yared decides to make a larger wedge that is mathematically similar. Now that's the key word there, they bolded it. Okay. Now if they're similar, there must be a scale factor. Okay. So to work out the scale factor, what I'm going to do is do the corresponding side. So I know 4.5 here. I want to go and find the corresponding side of this one, which is 3. And I'm going to do the larger corresponding side, 4.5, divided by the smaller corresponding side. So 4.5 divided by 3. And I get 1.5. I have timesed the smaller triangle by 1.5 to get the bigger one. So for instance, 3 times by 1.5 gives me 4.5. Now I need to just do 12 times by 1.5. So 12 times by 1.5 is 18. So that length, that horizontal length here, that's what it asked me to go and find, is 18 centimeters long. Okay then, so moving on from there, over the page. Again, with the numeracy paper, you're going to have to just take a moment, pause this video, read the question, get your head around what it's asking you. Okay, so it says a grass racetrack is shown in the diagram below. The region shaded in the diagram is the grass track. we're then told some information about the inner radius and the outer radius that they've drawn on here, so it's pretty self-explanatory, that bit, and 65. All of that's on there already. It then says, what is the total area of the two straight sections? And we've got another straight section here. Okay? Now, in terms of that, that's just a rectangle. I know that the full length here is 20, and I know up to here is 15. So that tells me what this overlap must be. It must be 5. And then we know that's 65. So literally to work this out is easy. It's just 5 times 65. And then because there's 2 of them, I'll just double it. Okay, that goes into my calculator. 5 times 65 times 2. And I get 650 meters squared. Okay, now the second bit, we're going to use this answer. It says calculate the area of the grass track. Now we've just done just the straight sections. So what they want me to do now is to go and work out what this area here is and what this area here is. Now the reason why I'm using highlighters to really demonstrate this is hopefully now you can see that those two are just going to fit together to make a full circle. So if I use this bit of space here to put those together, I've got one large circle drawn really well. And then we've got one smaller circle here. I know that this radius here is 15. Sorry, that's not supposed to look like a clock. To work out the shaded area, I need to do, so the shaded area, which would be, let's just highlight that in yellow. Not in yellow, sorry, in orange. To work out the shaded area, I'm going to do the big circle, which will work out everything here, but then I want to get rid of everything in the white circle. So I want to do shaded area is going to equal to the big area, take away the little area, or take away the small area. Okay, so what I need to do here is say curved area, maybe, shaded area, same thing. Curved area is equal to pi times radius squared, so pi times 20 squared, take away pi times 15 squared. Okay, that can go into your calculator. You might be able to do that bit in your head. 20 squared is 5. So if you take away 400 pi from 225 pi, you get 175 pi. I'm not going to press SD at the moment just because I know it's going to give me a really nasty number. To then work out the total area, the total area is going to equal the 650 that we worked out here from the straight sections plus the 175 pi meters squared bit. So then if I add 650 to that, we get the answer 1199.8 meters squared. Okay. And then the part underneath is really common in a numeracy paper and for a maths paper for that matter. It says the grass is to be treated with a fertiliser. It costs 20p to treat 3 meters squared of grass. How much will it cost to treat the grass of the racetrack? Now, I always go and make a formula out of what they've told me. They've just told me that 20p is equal to 3 meters squared of grass. I tend to go and write that. Look, they've even put it in pounds. We'll write that in pounds then. So 0.20 rather than 20p is equal to 3 meters squared. Well, I don't have 3 meters squared. I have 1199.8 meters squared. So what I want to do is work out what I times 3 by to get that answer. Now, using the full answer from here, if I do that answer divided by 3, I've times it by 399.926 blah, blah, blah. Whatever I do to one side, I need to do to the other. So times by 399.926 blah, blah, blah. So if I do that answer times by 20p, I get the answer £79.99. Okay, so £79.99, that answer there. Okay, this question here is ridiculously fussy just because it's got so much going on there. Take a moment to read through it, get your head around it. I will start just answering the question. I'm not going to read through absolutely everything. I'll show you what I did to answer this. Luckily, I've got 6 highlighters. They came in very handy for this question. Okay, then. So, we're basically asked, if you actually go and look at the question, if I move over here, it says, go and calculate the additional volume of water that feeds into Daisy's cylinder in litres. the number of minutes that Daisy Shower will run continuously before the water runs cold. That's what C is. C is that. T is the other one. Okay, so basically they want us to answer these two formulas. So what I did was I said, right, H, let's go and work out what that is. It says it's the volume of hot water in the cylinder. If you go and read through your question, it will tell you where that is, okay? So I'm looking for H. H is the volume of hot water the cylinder holds. It's that, so I now know what H is, okay? Now here, I would write what that number is as well. So in brackets, I can write there 300, okay? New highlighter, M. M is the temperature of the water in the shower. M is the temperature of the water in the cylinder, so it's not that. Temperature of the cold water that feeds into the cylinder, not that. The temperature of the water in the shower is 32, okay? This bit here is 32. New highlighter, X is the temperature of the hot water in the cylinder. Temperature of the hot water in the cylinder is 60. And then, we had another M there as well. It's repeated there. The cold water that feeds into the cylinder. So why is the cold water that feeds into the cylinder? That's 8 degrees. Okay. And then T is actually a formula, so I don't need to highlight that. And then F is the flow rate per minute, 26 litres per minute. Okay, so that's the flow rate. Okay, so F, do I know F there? H, I've already got them worked out, was here. And then C is what I work out there, and it comes into that formula there. Okay, so what I need to do now that I've colour-coded all of this stuff, is literally just substitute that stuff into the exam. So, into the formula, sorry. It's not the hardest thing in the world, but it's certainly fussy. The only way I got through this was just taking it line by line. Highlighters were really useful for me there. As you can see, it's all colour-coded now. It should make my life very, very easy. So I can write C is equal to H. H I know is 300. Bracket X. So X I've identified as 60. Take away M. M I've identified as 32. Now that number there comes here straight away, as you can see, M and M there. And then take away Y. It's the only bit I didn't highlight actually. Y is the temperature that feeds into it, so take away 8. So literally chuck that into your calculator the way it looks. Fraction button, 300, close bracket, open bracket, sorry, 60 minus 32, close brackets, 32 minus 8 on the bottom, equals 350. So we now know what C is. C is 350. So now to go and work out T. T is equal to 350 plus H. H is 300. All divided by F. So F was the flow rate, so F is 26. So again, just chuck it in the way it looks. Fraction button, 350 plus 300 over 26 equals 25. Okay then, over the page. Question 6. This was the last question on the intermediate paper. It says, Dr. Khan and her daughter Farrell have different opinions about the mean temperature in their hallway. Dr. Khan and Farrell recorded the temperature in the hallway at 4 p.m. each day of the 30 days of April. In her notepad, Dr. Khan summarised the temperatures of the group frequency table. Now, usually what we do is we and we can still identify all of these. That's going to be 20.5, 21.5, 22.5 and 23.5. But unfortunately, we don't know, the next column that we would make, don't actually know what this value is here. However, we are told there are 30 days in April, and that's the last one. So we've got 4 and 8, that makes 12, and 8 makes 20. So this number here must add up to 30. Okay, So we're on to 20 already, so that must be 10 that goes there. We then create a midpoint times frequency column. So we're going to multiply all of those together. So 20.5 times 4 is 82. Then we've got 21.5 times 8, that's 172. Then we've got 22.5 also times by 8, so I'm just going to change that one there, 180. And then 23.5 times 10 is 235. I now add up all of those numbers, so 235 plus 180 plus 172 plus 82 comes to 669. And then, to work out the mean, I do the total of the midpoint times the frequency, so 669 divided by the total frequency, the total number of days. To get 669 divided by 30 is 20. Oh, done that. Plus answer equals, there we go, it's back. 22.3 is my answer there. Okay, that's the same one that would go down the bottom here. Okay, over the page, it then says, what assumption have you made in calculating the estimate of mean temperatures? Now, in terms of the estimate, what assumption I've made, if I just come back to the question quickly, if I'm able to, there, I've assumed that all 4 days were exactly 20.5. Now, they could have all been exactly 20. They could have all been just under 21. I've just taken a guess somewhere between those two numbers, okay? And I've done the same for every category. Okay, so the way I'm going to word that is all temperatures were at the midpoint. Part C says Farrell recorded the same temperatures as her mother each day. She found that the actual mean in the hallway during April was lower than the correctly calculated estimate of the mean. Explain how this can be true. Well, basically because of that, I've assumed that all the temperatures are at the midpoint. So I'm going to say every time the temperature was less than the midpoint. That's why it's called an estimate of the mean. So we don't know it's definitely that. It's an estimate because we don't know what the values are between the categories. Okay? Okay then, question 7. It says Gwen fills a 10-litre bucket with water from a tap. She turns the tap until it is fully open. The bucket fills up with water. When Gwen thinks it is close to being full, she slowly closes the tap. The bucket is full after 20 seconds. After how many seconds did Gwen decide to close the tap? Okay, so what I'm looking to do is that if I'm looking at the volume of the water going up, I can see there it's absolutely flying into the bucket, and then here, right at this point here, something happens to completely slow down the volume of that water. So the fact that it starts having a slower gradient there is telling me that we must have turned the tap off there. I'd expect if we hadn't touched the tap for that line just to be consistent throughout. Okay, so coming off and reading down that, it's 2 little squares short of 10. And then if we read off the scale here, 0 to 5 in 10 little squares is 0.5 per little square. So 2 little squares back, that would be 9 seconds. Part B says estimate the rate water is entering the bucket at t equals 10 seconds. Give your answers in litres per second. Now, you need to know that if we need to go and draw a tangent to that point. So I'm looking at 10 seconds, and I'm going to draw a tangent there. Now, the first thing I'm going to do is literally just make a mark with my pencil on it, and then I'm going to get my ruler above it, and I always think of a bow tie. Now, a bow tie, if it is tied correctly, will have the same amount of area of material on each side. You do not want to have a lopsided bow tie. For instance, you wouldn't go out dressed like that, or you wouldn't expect to see someone dress with a bow tie that did either of these situations, okay? They should have the same area each side, so you want it like that, not like that, or that, okay? So at 10, I'm looking for my area just straight after. Obviously, this graph here changes, but can you see here, this area is going to be a lot bigger. So I just want to try and make sure it follows generally the trend of that graph. So I think it's going to look something like that, okay? It shouldn't look like that, where there's hardly any area at all and loads of area straight after it. Should be just to the left and to the right. This should look like it's about the same if that curve continued, okay? I think that's a reasonable shout there. Okay. Get 1 mark for drawing that tangent. And now what I need to do is draw a triangle on it and work out the difference in gradient. So I always say it's rise over run. So what I'm going to do is look for a really nice rise. Now I know this whole 10 little squares account for 2 in units of litres. So I'm going to count this one here. I'm going to come all the way up to here so I've got a nice number and see what value this is here. Okay, so drawing up from there, I know this rise is 2. And now I've got to work out how long in units this is. Now I've already worked out that the scale is telling me that 2 little squares is worth 1. So if we count that there, there's 1, 2, 3, 4, 5, 6. And the first time I actually got exactly 6. It's fine as long as yours is accurate. They do not need to be the same numbers as mine, as long as you've drawn a tangent to the best of your ability that looks like it has just after it roughly the same area each side, which I think mine does. And then you need to use the formula rise over run. So how much my graph has risen, which is 2, over how much it's run across, 6.5, and that's my answer, okay? Over the page, it says, when the tap is open, is fully open, water flows out at 2 litres per second. Express 2 litres per second in gallons per minute. You must show all your working. Okay, well, the first thing I'm going to do is, because they want me to work this in litres, and then I can't see litres in there, I'm going to use another conversion that I need to know. If you don't know this conversion, you need to learn it. 1 litre is equal to 1.75 pints. There's only about 4 that you're expected to know, like miles to kilometre, pounds to kilograms, litres to pints is 3 of them off the top of my head. Okay, now that I know that in pints, I can then use that formula that you've given me there. Okay, now to go from here, I know that we're getting 2 litres per second. That's what they told me here, 2 litres per second. So double of 1.75, 3.5. Let's just double check. We have a calculator after all. 1.75 doubled is indeed 3.5 pints. Now that is per second. I want to work this out per minute. So to work it out per minute, I need to times by 60. Okay, so what I'm going to do is times both sides by 60, not 66, times by 60, and 2 litres, so it would be 120 litres times by 60, and 3.5 times 60 is 210 pints per minute. Okay, now I know that it's 210 pints per minute. I'm going to write down my other formula that I've been given, which is, I'll just do it so it's out of this one here. 1 gallon is equal to 8 pints. I'm going to put an arrow down there and equals. I'll get my pints, my 210 pints are going to go here. And what I want to do is work out how many 8s fit into 210. So if I do 210 divided by 8, I know that I've times this by 20 side by 26 and a quarter. 1 times by 26 and a quarter is 26 and a quarter gallons, so 26.25 gallons. Okay. And then part 2, it says, can a fully open tap fill a 90-gallon tank in under 3.5 minutes? Well, I know that 26 and a quarter gallons is equal to 1 minute. That's what I've just got and worked out here. We've worked this out per minute, so I can effectively say that this 26.25 gallons is equivalent to 1 minute. I want to know how many gallons of water I can get out in 3 minutes. What do I do to 1 to make it 3? Times by 3. Whatever you do to one side, do to the other. So it's 26.25 times by 3 to get 78.75. Oh, no, it's not. It's times by 3.5. 3.5 minutes. So 26.25 times 3.5 comes to 91.875 gallons. And then just make sure that you've answered the question. Can a fully open tap answer that in 3.5 minutes? So times by 3.5 times by 3.5, that's 3.5. Well, the answer is yes, because it wanted a 90-gallon tank. We can do slightly more than 90, okay? So make sure that you say yes. Okay. Okay, next question. It says the head teacher of a school wants to display pictures drawn by pupils along the side of the corridor. We've got a long corridor there, then we've got the pictures. The pictures are all square. The sides are 15 centimetres correct to the nearest 0.5 centimetres. Right, well, straight away, there's your question. You need to divide that by 2 to get 0.25 centimetres. You need to go and work out the lower bound and the upper bound. If it ever tells you nearest anything, nearest centimetre, nearest 5 centimetres, nearest whatever, always divide it by 2 to find that and then take it on and take it off to find the upper and lower bound. So let's do the pictures. So the pictures, the lower bound is going to be equal to 15 centimetres, take away 0.25, which is equal to 14.75 centimetres. The upper bound of the pictures will be 15 plus 0.25, so that is 15.25 centimetres. The wall, now this is what they normally do. They normally have them in different units of measure, but for some reason they've said that is 2,010 centimetres. So I'm surprised they're not saying it's 20.1 metres. I would have expected to see that in all honesty, but they haven't. So let's enjoy it while it lasts, because usually we have to get the units of measure the same. So we want to take away 5 centimetres to the wall, so it's 2,010 take away 5, which is 2,005 centimetres. The upper bound would be 2010 plus 5, so 2015 centimetres. Okay then, so to work out what they wanted, it says calculate the smallest number of pictures and the greatest number of pictures that can be fitted. Okay, you need to think like an optimist and a pessimist here. The optimist would say, right, to get the most number of photos, or the most number of pictures, the wall could be the biggest it could possibly be, and the photos could be the smallest they could possibly be. You will most likely, not definitely, be working cross purposes here. So upper bound of one, lower bound of the other. If I do 2015 divided by 14.75, I get 36 and a bit pictures, or 136 and a bit pictures. So the greatest number of pictures I could get is 136. Okay, 136 and a bit, it doesn't matter, even though that would mathematically round to 137. If I can only get on 0.6 of a picture, I can't get it on. To get the lower bounds of the wall, so if we say, oh, hang on, what if the wall's not as big as we thought it was, and the pictures are bigger than we thought it was, we'll get a smaller number of photos. So by doing 2005 divided by 15.25, that will work out the least number of photos we could get up there, the least number of pictures, so 15.25, and we get 131.47, blah, 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 so 131 and a bit, so 131. Okay, again, think about it logically. The more stuff I have divided by the less things is going to give me a greater answer. The smaller number divided by a greater number of things is going to give me a smaller answer. Okay, think of it like money. If I had £2,015, that's better than £2,005. Sharing it between less things gives me a bigger answer per person. Okay. Okay, then, so the next question is about AER for the first bit. Now, it says nominal annual interest rate is not the same as AER. That's true, okay? They're not the same thing. Accounts for giving interest on your interest, whereas nominal interest rate doesn't, okay? The next one says, and a savings account offers a nominal annual interest rate of 2% paid monthly. After a year, any investment will have increased by a value of exactly 2%. Well, the whole idea of AER is that you get interest on your interest. So after a year, if that's paid monthly, I'm going to be slightly more than it says that. So that's false. A savings account offers an AER of 2.4% with interest paid monthly. The monthly interest rate offers will be exactly the same as 0.2. Well, that's not true either, okay? So 2.4% of an annual equivalent rate. You would do 2.4, divided that by 12 to get 0.2, which they've got there. But you would then get interest on your interest, so it'll be ever so slightly more than 2.4%, so that's also false. And then it says £100 is invested in a savings account which pays monthly interest rate of 1%. There are no further transactions into or out of the account. The amount in the account after the year will be 112. Well, that's exactly the same as that question in disguise, okay? You get interest on your interest. It'll be slightly more than saying, right, 1% times by 12. You'll be on slightly more, okay? So I make that we've got true and 3 falses, not necessarily 2 trues and 2 falses, okay? Now, just be very, very careful with the question underneath, because I got myself into a bit of a flap with this one, purely because I'd seen that table there. I assumed that I needed to go and use the AER formula from the front page, or from page 2. But if you read the question, you don't need to at all, okay? But you do need to be good at working out with multipliers. It says Benjamin pays in £1,000 into an account that pays interest every 6 months. He does not make any further payments into the account and does not withdraw any money either. After a year, so we've gone from 6 months to a year, there is £1,036 into the account. Calculate how much interest was paid after 6 months. Okay, so the way that we're going to do that is we know that the initial investment was £1,000. We're going to times that by the interest rate, which we don't know. Now, that's paid every 6 months, and this is after a year. So I times that by x again, or it happens twice, okay? So I'm going to say it's times by the multiplier squared, and that would give us our final amount, which would be 1,036. Next, I'm going to start trying to work out what x is. So I'm going to get rid of the times by 1,000. I'm going to divide both sides by 1,000. To get x squared, my multiplier squared would be 1.036. And then to work out what the multiplier must be, I'm going to square root both sides to get x is equal to the square root of 1.036. So if I do that then, square root of 1.036 tells me I've got 1.01784 0852. If unsure, always write out the full thing. And then what they asked me, calculate how much was in his account after 6 months. Now, what I'm going to do is just show you that works so far. So £1,000 times by that answer squared should give me 1,036. It does. I need to get that back now. So there we go. I've got that back. So after 6 months, you do the amount of money that you had times by the multiplier. Now, it's only after 6 months, so answer, I didn't mean to write that. I want to say 1,000 times by 1.017 to get my answer of, I will use answer on my calculator, £1,017.84. Okay, quite a fussy question that. It's not as easy as they normally are. And you had to do a little bit of nasty rearranging of the formulae as well. Okay, so question 10. What I'm going to do is use my highlighters again to try and put some of the information in on the diagram. Now, they normally put the numbers on, they haven't here. So they tell me here that the prism has CD, so CD is 8 millimeters, okay? They tell me that DE is 8 millimeters also. They tell me that CE is 11.3. They tell me that BC is 10. Okay. Now, also, one thing that I did miss was that the cylinder has a diameter of 6. It's that. And a length of 9. That's a length of 9. Okay. Now, I haven't actually read the question, so I need to read the question. I think I know what it's asking me, but let's just be sure, okay? it says the company makes shelf supports for use in kitchen cupboards. A shelf support is made by attaching a cylinder to a right angle triangular prism. All that information I've just got and put onto the diagram there. It says the company needs to sell the shelf supports in packs of 500. It needs to know the volume of plastic in 500 shelf support. So what I need to do is work out the volume of each of these things, okay? Add them together, that'll tell me the total volume for one, and then I'll times that by 500, okay? So the first thing I do is work out the volume of the cylinder. Volume of the cylinder would equal pi r squared h. Pi r squared is the volume of the circle, is the area of the circle, times by the length would give me the volume of the cylinder. So be careful here, that's pi times 3 squared because we were told the diameter, and then times that by the length of 9. Now, I'm actually going to leave that in pi. Pi times 3 squared, that's 9. 9 times 9 is 81, so that's 81 pi. And then I'm going to work out the volume of the triangular prism. So the volume of the triangular prism would equal the area of the cross-section, so the triangle, area triangle, times by the length. Now, they've actually given us 4 measurements there. They've given us the blue, the yellow, the orange, and the pink. That orange one's irrelevant because I'm looking to do base times height where we've got a right angle. It's just there as surplus information. We don't need it at all for this question. So the area of the triangle would be the base times the height, so DE blue, which is 8, times by yellow, which is also 8, divide that by 2, and then times it by a length of 10. I can actually do that without a calculator. 8 squared is 64, half of that is 32, 32 times 10 is 320 millimeters cubed. Could go and put this up here as well, millimeters cubed. So then the total volume for 1 would equal 320 plus 81 pi, and then the total for 500 would equal 320 plus 81 pi, put that in brackets because there's 2 of them together, times by 500. Okay, so bracket 320 plus 81 pi, close bracket, times by 500, gives me an answer of 287 234.5 millimeters cubed. Okay. Oh, I had loads of space on the other side anyway. Did I, or was that for another question? Oh no, it's this question here. Okay. Okay, again, read this question, pause the video, get your head around this question. It is a really tricky question, okay? I'm going to go through it very quickly, but just make sure you've read it first. Okay, it says, the company also makes a metal door handle for kitchen cupboards. One of the door handles it makes is shown below. It is formed by joining 2 cylinders. One of the cylinders has blah, 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 which they have shown us this time on here. The other cylinder has blah, 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 which they've shown us again here. Now, in terms of what we're asked then, it says, at present, the company paints all surfaces of the handle with a protective finish after the 2 cylinders have been joined together. Okay, so we're going to have this side painted that I can't see, all of this distance around the circumference, this one here, this cylinder here, and then this end as well. Okay, the shaded circular face is pressed against the cupboard door when fitted. In future, the company is not going to paint the shaded, so they're just not going to paint just this one tiny little bit. This is to reduce costs. Calculate the percentage reduction in the area that is painted. Okay, so we need to go and work out the areas, the surface areas of each of these things here. Okay, now because we're working surface areas, we're going to be working with radiuses rather than diameters. So I'm just going to go and write in the radius for each of these here, so I don't get myself confused. Okay, I'm going to call this bit here A, and this bit here B. Now, when I cut that and stretch it out, it will effectively make a rectangle. Okay, that is going to be the area of B. Now, this length here, this is the circumference of this thing here. If I cut that and then stretch it out, it'll just be one long straight line. So that is going to be C equals pi times by diameter. In terms of this length here, that will be the 3 centimeters from there. That's how long it is. Okay, so to do C is equal to pi times diameter, C is equal to 1.8 pi here. Okay. Now, similarly with this one here, if I cut it there and stretch out, I'll make a much longer, much skinnier rectangle there. Okay, that's what that would look like if I cut it along the top and stretched it out. I know what its width is. It's 1.2 centimeters. And its length would also be the circumference, okay, but of a much larger circle, okay? So it's going to be C is equal to pi d. So the diameter is 4, so it's going to equal to 4 pi, okay? So I'm going to work this out currently. So I know the current area that is painted, okay? So I'll say here, currently, we are going to have, now for this circle here, we're going to have pi radius squared, which is this side here that I can't see. Then we're going to have rectangle A, so it's going to be 4 pi times 1.2, so I'll put that in a bracket so those two are done first. Then it is going to be this large circle again, the same one as this side, so pi 2 squared, but I'm not going to have this small circle because they're pressed against painted. Okay, so it's going to be pi, the radius of this is 0.9 squared. Okay, I'm going to put that into my calculator in one long line. So pi brackets 2 squared. If you want to, you can answer certain bits of it. So like 4 pi. 4 pi times 1.2 plus pi bracket 2 squared, and then take away pi bracket 0.9 squared. That gives me an answer of 37.66 blah blah blah. Now, I very rarely round these answers until I'm finished. However, this is the one time I am going to make an exception. If I try and write all of that out, it's going to be a nightmare to do this question. I'm going to round it to 1 decimal place, okay? So currently, just this area here, minusing this bit here, comes to 37 centimeters squared. Okay, that's to 1 decimal place. Now that was working with circle A. I'm now going to do the same for circle B. So to work out circle B, we don't have that circle there. And then B is this rectangle here. So it's going to be pi, 1.8 pi times by the length, so times by 3, and currently they do paint the circle at the end, so pi times by 0.9 squared. Okay, so I'll work out what that is, brackets around those to make sure they're done first. Done here, 1.8 pi times by 3, and then add pi 0.9 squared, gives me an answer of 19.5 centimeters squared to 1 decimal place. Again, I'll make sure that I've identified that I've rounded. So its total area that is currently painted is 37.7 plus 19.5, which equals 57.2 centimeters squared. Now, I've absolutely crammed all that in on one page just so that I could keep on referring back. In the exam, you should have gone and used this paper as well. It's just that I haven't got it as one page. I can't get it all into the visualizer. Now, going on to the other page, what I need to do is work out, it says, calculate the percentage in reduction that the area is painted. So what I need to do is work out how much area this shaded circle is, and then divide it by what the total is, or what the previous total was, that 57.2, and then times that by 100, okay? So I'm going to work out the area of this shaded circle, so that's going to be pi brackets 0.9 squared divided by the total area that used to be painted, so 57.2, and then times by 100, and that will tell me what the percentage reduction is. So, brackets, pi, brackets 0.9 squared, over 57.2, to the side, times by 100, comes to 4.44 or 4.5% to 1 decimal place. So the percentage of the reduction of what's being painted is 4.5%. If you found that question hard, you should have. That was a challenging question. It wasn't easy at all. Okay, on to the last question again. Pause the video, have a quick read of the question, get your head around it, and then press play and I'll start going through it. Okay, number 11. A sensor can detect any movement up to a distance of 6.5 meters. A storeroom is in the shape of a cuboid, as shown below. The sensor is placed at A so that it is aimed directly at B, where BD is equal to 2 meters. The front of the sensor is 20 centimeters long. Now, highlight that bit. That bit's really important. I missed that the first time I did this question and got the answer wrong at the end because I missed that bit there. I just went straight into answering the question without really thinking about what to do. It then says, will the sensor be able to detect movement at B? Okay, so I'm going to have to go on to 2 pages, but let's just try and work out what's going on. So, to work out the movement at B, I need to know how long this dotted line is. Now, to work out that dotted line, I know that it's 6.5 from the sensor there. I need to know how long that is, okay? So what I'm going to do is join this up here. Now the reason why I'm doing that is because I know I will make a right angle triangle there, and I know that's 3.2 centimeters, so that's 3.2 centimeters, not centimeters, meters there. The problem is I don't know what this length is, but I've actually made another right angle triangle here, okay? The fact that we're on the last question and we're looking at 3-dimensional cuboids should be telling you that we're going to use Pythagoras and trigonometry on this question. Now, the good news is because I know this side and this side, I can work out this side here. It's just using Pythagoras, which we've already done once in this paper. The right angle points at the hypotenuse, so that's BE. So I'm going to say BE squared. Let's make sure you can see what I'm doing. BE squared would equal to 2 squared plus 5.5 squared. So BE would be the square root of those two added together, which I will now do on the calculator. So 2 squared plus 5.5 squared is 34.25. Square root of that is a horrible number. Okay, now we can't round this unless we absolutely have to, like we did on the last question. So I'll just say that for now. So now we know what this length is here. It's 5.58, sorry, it's 5.85, blah, blah, blah. I now know this length here and this length here, okay? Then, spotting that right angle triangle, I can try and work out what that length is. Now, to do that, I want to do the 5.85, 234, blah, 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 squared, plus 3.2 squared would equal BA squared. Okay? Now, to get from there, I'm just going to literally do exactly the same thing as before. Let's say ANS squared plus 3.2 squared comes to 44.49. Square root that to get BA. And I get 6.67 meters there. Okay. Now that equals BA. But this is where I went wrong. You know where I said about highlighting this bit of information before? What I've got and worked out is this distance all the way to the corner here. Okay? Now we're told that that distance there from the front of the centre to A, there's 20 centimetres. So what I need to do, I looked at that and said, well, it's 6.5 meters. For a second, just because my camera froze. I looked at that and said, well, it's 6.5 meters squared. I've worked out that's 6.7, but I didn't take account of this bit here. So this bit here is 20 centimeters long, which is 0.2 meters. Okay, so basically, I know all of that distance there is 6.67, but I need to get rid of that 0.2 meters. So if I do 6.67, take away the 0.2, I find out that this is 6.47 meters. So my answer is yes. It will detect at B. Okay, it's literally right on the cusp, 6.5 meters. So you've got another 3 centimeters you could have had out of it. Okay. It then says, show that BAE is 61.3 centimeters correct to one decimal place. So BAE, go from B to A to E, it wants me to work out what this angle here is at the top. Now to do that, I need to know a couple of things. I need to know what its opposite side is. So op here, I need to try and work out what I've got anyway. I know what its adjacent side is. Now, I do know what its hypotenuse is, but it's that long number there that I just worked out. I wouldn't use that at the moment, okay? So I'm going to work with opposite, which I do know, and the adjacent, which I do know. So using SOHCAHTOA. And then I'm going to work with O and A. So crossing out O and A, SOHCAHTOA tells me to use tan angle. So I'm going to say tan theta for the angle is equal to the opposite, which is that 5.85. Now, the way I got 5.85 before was square rooting 34.35, is it? No, 34.25. That gives me that answer there. So that 5.85, 234, blah, 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 divided by the adjacent side, which is much nicer, it's just 3.2. To then go and work out what that angle is, I want to do inverse tan of both sides. So tan minus 1, tan minus 1. To get theta 5.85 dot 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 over 3.2. And then I'll work out the angle. It should be 61.3 if I've done it correctly. So tan ans over 3.2 equals 61.3 to one decimal place as required. That was the last question on this higher tier paper. Hopefully you found that useful. If you did, please hit the subscribe button and you'll get access to any more videos as and when I release them, as I'm trying to add videos quite regularly at the moment. I hope you found that useful. Thank you very much for watching.